Not again. Come on, which one? Oh. Okay. Let's have a look. Right, so the question now. From an observatory on Earth, Mars is observed as having two moons. One of the moons, called Phoebus, is observed as orbiting Mars at a distance of 9,380 kilometers, and its orbit takes 7.65 hours to complete. Finally, the radius of Mars is estimated as 3,390 kilometers. NASA is planning on sending a small probe to Mars. Help NASA. You may assume a circular orbit. Alright, so anyway, let's have a look. Right, so the first part is the mass of Mars. So we should use Kepler's law here. What is it? T squared equals 4 pi squared over gm. Gm squared?
No, gm.
Gm. And what do we want? The mass?
Yes.
So the mass equals 4 pi squared or cubed over gt squared. Yeah, so that's 4 pi squared. And the radius of the orbit of the moon now, is it? Now, you see what we're looking at here is Mars, and here is the moon. So we're looking at this one. So I think this here is 9,000, yeah. And the time is 7.65 hours. What do we get? These
4.6. 4.66 times 10 to the power of 23. At least that's what I got. 6.44.
Ah! You got it literally backwards. 6.44
times 10 to the 23.
Great. Okay.
No.
You get this? You get this? Okay. Continue? Yes? Okay. B. How fast is Phoebus moving? So we can use the formula V equals omega or, which equals 2 pi over t, or which equals 2 pi over 7.65 times 3,600 times 9380000. What do we get?
2,140 meters per second.
2,140
Yeah.
meters per second.
Should you remember that formula?
Which formula?
T squared equals 4 pi squared.
Yeah, this one here?
Not in our
This is not in the book. Which one? This is Kepler's second law. K2 we'll call it. Yeah, it's not in the book. Yeah? Yeah? Oh, next we have V1 or 1. Isn't that it? Equals V2 or 2. This is Kepler's third law. Yeah. So we have two possibilities. We want to know what's the slowest and what's the fastest. So we have V1 or 1 equals V2 0, it's going the slowest when the radius is the biggest. So this is when it's 10% extra. And this is when it's 10% minus, yeah. So what's nice is I actually don't really need to know what the radius is. I can cancel it. So you get this neat result that V2 equals V1 over 1.1 and V2 equals V1 over 0.9. So V slowest will be 2140 over 1.1 and V fastest will be 2140 over 0.9.
First one is 1945 and second one is 2370.
Got that? Next is D. Density is mass over volume, which is 4 over 3 pi r cubed. And what was the mass? It was 4.6. What'd you say, Harian?
I forgot what it is.
6.44 multiple 10 to the 23.
23. Okay. So that would be 6.44 times 10 to the 23 over 4 over 3 pi, and then the radius I see is 9380000. So what do we get?
It's not 938. 938 is from the.
Oh, sorry. Thank you. It's 3390000. Yeah.
Maybe 3,000.
3,946 kilograms per meter cubed. Yep. E. What is the gravitational field strength? So that's G equals Gm over R squared, which is 6.67 times 10 to the minus 11 times 6.44 times 10 to the 23 all over 3390000 cubed. Got your calculator? Great. What's the answer here?
1.1 times 10 to the power of -6. Is that correct?
It is not. Sorry. Squared. Sophie, you have your calculator? Amanda? This, please.
No, check.
No, what did you guys tell me?
3.7
3.74. No, too big.
I just got that.
Is this the right point?
No.
Yeah, that's just it.
3.7.
3.74.
3.7.
4.
That's it.
Thanks. 11, not minus 11.
The unit can also be mass negative to
It's not normal, but it could be. The next part is the Parkin orbit. You can't do F because I left out a piece of information. I'll have to check it for you. Unless somebody got an answer. Yeah. What did you say the time was?
I just say time was 7.65. 2000.
No, that's for the moon to go around. We need to know how long a day is on Mars. It shouldn't be 24 hours. Does anybody know? It's like 25 hours or something? It's a little longer? Or is it a little shorter?
We'll find out.
Yeah, type in how long is a day on Mars.
One day and 40 minutes.
Really? So it's nearly the same as Earth. How long is a day on Mars? How long is a day on Mars?
Searching on Google to get answer results.
Yeah. Oh, yeah. Sorry. As a top result. Yeah. It doesn't matter. Here it is. In fact, a day on Mars is 40 minutes longer than a day on Earth. So it's nearly 24 hours as well. So here a Parkin orbit will be when the time is 24 hours and 40 minutes. So that means the time is 24 times 3,600 plus 40 times 60. What's that, please? $88800. So we can have again t squared is 4 pi squared or cubed over gm. That's it, isn't it? So that means or cubed equals gmt squared over 4 pi squared cube root. So that means or equals cube root 6.67 times 10 to the minus 11. And what's the mass? We had it earlier. 6.44 10 to the 23. Times 88800 squared all over 4 pi squared. No, I cube rooted both sides.
Okay.
Yeah. Say again, 20.
4, 7.
Sorry, let's start again. 2, 4.
2, 0,
Yeah.
4, 7.
Yeah.
1, 9, 5, 4.
Okay, so that is 20,472 kilometers. That's 20,472 kilometers. But you have to be careful here because that's the distance from the center to the probe. But I want this distance. So that would be 20472 minus 3390. So what's that now? 17. 17082, is it? So
7, 4, 8.
2. Yeah.
So, like, accurate is 170782.
17.
07.
But I got 17082.
Yeah, that's what I thought.
I calculated all of them.
Okay. It's about this.
Can you zoom out a little bit?
It's about 17,100 kilometers if we go 3 significant figures. Okay, next.
Wait, I need to zoom out a bit.
Next is G, which is what's the field strength. So that's Gm over the field strength here. So that's Gm over R squared. So that would be 6.67 times 10 to the minus 11 times 6.44 times 10 to the 23 all over 20472,000 squared. And this should be small.
Sorry, but what is the name of S equal G multiple M multiple small n over R?
Newton's law of gravity.
Different from
Yes.
or small n.
Yeah. Oh, well, sometimes I use small. Maybe I'm using big M, so it's for the Mars, isn't it? Yeah. 0.10. Okay. And finally, the total energy is kinetic energy plus potential energy, which is a half v squared minus g m over r. Potential energy formula was minus. Do we know the V? No, but we know that V equals omega R. Well, maybe I'll use a big R. Minus G M over R. And do we know omega? We don't, but we know that omega is 2 pi over T. Right, so it's a half, and the satellite is 100 kilograms, and it's 2 pi, and the time is 88800, and the radius is 20472,000 minus the radius 2047200. 6.67 times 10 to the 23. 6.67 times 10 to the minus 11 times 6.44 times 10 to the 23 times 100. Minus? Minus is okay. What you get? Do you have minus 11 here?
Yeah.
Here. Okay, what you got? Minus
19933310185.
joules.
5858.
5, what?
58.
Not 85.
Yeah.
58, like this. Well, it doesn't matter. 1, 2, 3. 1, 2, 3. 1, 2, 3. So that's about minus 2 gigajoules. Giga is 9. You got the same answer, Harry? Yeah.
Negative 1049, 1039.
You got a different answer?
Same as
Okay, go ahead. What you get? Wait. Minus 1049 1039 2. 1, 2, 3. 1, 2, 3. Right, so that's minus 105 megajoules.
So do we answer negative or can we remove the negative?
Now, in this case, the negative is important because it tells us that it's trapped. So you could interpret this answer as to free the probe from Mars, a total of 105 megajoules of fuel energy is needed. So if you wanted to free this satellite from Mars, it would need to burn 105 megajoules of fuel.
Yeah. 10
Yeah. Maybe I'll make that an extra question for next year. The question would be, what does this number mean? Say again? You missed O? Okay. You see this more often in chemistry when the electron is trapped around a proton. Can you see how this is similar to that? You have the satellite around Mars, it's the same as the electron around the proton. What do you call in chemistry the energy you need to free the electron from the proton? Oh, you know it. You know it.
Yes.
You know it.
Wait.
You know it.
To free the electron from the proton.
Yes, what's it called?
Ionization.
Ionization energy. Yes?
Possible.
Yes. So this is like ionization, so to speak, of the satellite from the planet. You need that much energy to free it. Yeah? Do you calculate or do you talk about how much energy you need for ionization? Like, do you use joules?
We just, what do we use? I think it's kilojoule.
Use kilojoules for ionization?
Maybe ionizing just joule. I know.
Okay.
Like joule.
Okay. Close this. I can close this?